Last time, we discussed that if we can quantify all the parameters within code that affect the final code quality, we will be able to accurately predict the quality of the code produced. So today, let's first try code prediction for a single code type, or rather, an online mini code oven test for a single code. This is our big data prediction model. It includes the online mini code oven test, intelligent resource optimization, cost effectiveness ranking, and a code blend result prediction, among others. This lower section shows the code sources commonly used in a plant. The parameters include proximate analysis indicators, code maceral indicators, and code ash indicators. There are also code forming period indicators, followed by several other parameter indicators. Let's enter the single code mini code oven prediction model. We will select two fat codes with nearly identical proximate analysis indicators for a comparative test. First, we select one of the best domestic fat codes from Puxian, Shanxi. We select it from the database and input it into the online mini code oven test model. Begin prediction, reading out the result. Let's take a look. The volatile matter for this Puxian fat code is 31%. Sulfur is 4%. G value is 95, X value is 39.5, and Y value is 35 mm. The predicted cocoa strength is 85.1, the hot strength is 71.6, and the sulfur conversion rate is 0.83. Next, we select a fat coal from the western region with similarly good proximate indicators. Select it from the database and input it into the online mini code oven test model. Begin prediction, reading out the results. The proximate indicators for this western fat coal are close to the Puxian coal, except the sulfur content is significantly lower, only 0.3%. Now, let's look at the code prediction results. Coal strength 66.1, hot strength 20.8, sulfur conversion rate 1.38. We list the comparison of the main parameter indicators and predicted results as follows. The VM, caking properties, and plastic layer thickness of the Puxian and western coals are basically the same. However, the vitrinite content of the western coal is 38 points higher than the Puxian coal. There are also significant differences in their ash composition. Comparing coke results, Puxian's coal strength is 19 points higher than the western coal, and its hot strength is 50 points higher. The sulfur conversion rate of the western coal is 0.55 higher than the Puxian coal. Let's go back to the western coal test model to see where the problem lies. The first difference between these two coals is the vitrinite component. Let's adjust the vitrinite content to match and see the impact on cold and hot strength. The result is out. Cold strength increased to 82.7, nearing Puxian's level. Hot strength increased by 7, currently at 27.8. The second difference is the coal ash composition. Let's look at the few main components individually. Adjusting calcium oxide to Puxian's level. The hot strength increases by another 32 points. Adjusting iron 3 oxide to Puxian's level. The hot strength increases by nearly 10 more, reaching 69.7. At this point, we can see the predicted coke results for these two coals are basically identical. Meanwhile, the sulfur conversion rate for the western coal dropped significantly, nearing that of the Puxian coal. The coke sulfur content for the western coal has been adjusted from 0.11% higher than the coal to 0.05% lower than the coal. Alright, some of you may have doubts about these tests. That's fine. You can send in a known coal sample for a comparison. What is certain is that these online mini oven test results will never produce two different outcomes, like two physical mini ovens might. In fact, they will be much closer to the average value of two physical tests.